Welcome to an algebra tutorial video. We're learning about linear modeling, which takes linear equations, slopes, forms of linear equations, and graphs, and we use them to help understand and model situations, patterns, things we see around us. So here's a word problem we're going to work on tackling and using linear equations to solve. Krista purchased a used car with 45,920 miles on the odometer. After driving for a year, the odometer now read 53,402 miles. Write a linear equation to model how many miles Krista drives per week and how long it will take her to reach 100,000 miles on the odometer. Okay, the odometer again just tells you as the car drives and drives, it keeps track of the total amount of miles that car has driven. It's important in terms of the cost of the car and how much value it has left, resale value, etc. Okay, so let's think about what information we have here. Again, anytime we're trying to do linear modeling, I need at least 2 points to be able to plot 2 points and then use those 2 points to find the average rate of change or the slope. And then I can write a linear equation to model the problem. So we need to find if we have a couple of points here. All right, so when I interpret this, so she purchased a used car and there's this many miles on it. So I would read that as right when she buys it, so after 0 weeks, that car has 45,920 miles. And I'm only using weeks because I was asked to write a linear equation to model how many miles Krista drives per week. All right, so we got keeping track of weeks here and miles. There's actually 1 point. When she goes 0 weeks, we've driven 45,920 miles. I'm also told after 1 year, the odometer now reads 53,402 miles. So 1 year is 52 weeks. So after 52 weeks, we now have a mileage reading of 53,402, that many miles. And now we have a couple of points we can work with, and we can understand how we want to define our variables. Let's let x represent the number of weeks that she's owned the car. And let's let y represent the number of miles on the odometer. So defining your variables is really important as you're doing word problems like this, as you're trying to understand what's going on, because it helps you get to the answer, helps you actually work through the problem and understand the context of the problem. Okay, so we got 2 points. We've translated this problem. We can start doing some linear stuff with it. Let's first find the slope. So what is the average rate of change here? So we're dealing with weeks, we're dealing with miles. On average, how many miles does Krista drive per week? Well, to find the slope, m, that's your change in y values. So I need to subtract my y values, divide that by my change in x values, and we'll have the slope. So on my y values, we had 53,402 minus 45,920. There's the change in mileage. And we're going to divide that by how much did you change in weeks? 52 minus 0. That one's easy. So we can see that, let's subtract on the top now. 53,402 miles minus 45,920 miles. That's a change of 7,482 miles. So over that 52-week period, 52 minus 0, so over 52 weeks, she increased by that many miles. So there's a ratio of miles to weeks. That's how much change happened. Over 52 weeks, you changed 7,482 miles. If I divide those, again, we want to know a rate, how many miles per week. So I'm going to take 7,482 divided by 52, and we get equals 143. I'm going to round this to 0.9. It's 0.884, but let's round it to 0.9. So 143.9 miles per week. That's the slope of the line. That's the average rate of change. So let's circle that. Let's keep that handy. On average, she goes 143.9 miles per week. Probably some weeks she goes more, some weeks she goes less. We're finding an average over this 52-week period. All right, we got the slope of the line. Great start. We still want to get to a linear equation, and we want to think about, okay, how long will it take to reach 100,000 miles? All right, let's use point slope for. Let's actually think about my points here. So we have 0, 45, 920, and then we have 52, 53,402. Notice we have this first point at 0 weeks, she has that many miles. This is actually kind of a special point in even recognizing this is just the y-intercept. This is our starting value, and when x is 0, anytime you see an x value of 0, the y value that goes with it is the y-intercept. So we don't even have to use point slope form to write an equation. We can just jump right to slope intercept form. Remember, y equals mx plus b. M is the slope, b is the y-intercept, and I know both of those things in the problem. I know the slope and I know the y-intercept. So if I want to write an equation then, we have the equation y, the amount of miles she's going to have on her odometer is equal to 143.9 miles per week times however many weeks we're working with. So I'm putting x for number of weeks. But when she bought the car, there were already 45,920 miles on it. So there is an equation that we can use to model this problem. All right, we've got our slope, we've understood it, we got an equation, the equation makes sense. We're again trying to connect meaning as we're doing all this algebra. We still need to figure out, well, how long, there's the question, how long will it take to reach 100,000 miles? Well, 100,000 miles is a y value, and so if I want to solve for that particular y value, I'm going to put 100,000 in for y, and I'm going to solve for the value of x. So I'm running out a little bit of room here, but I'm going to write this equation, 100,000 is equal to 143.9 times x plus 45,920. And I need to solve that equation for x. It's a two-step equation, so it's not a difficult one, but I need to solve it for x to figure out, well, about how many weeks will it take. All right, so I'm going to run through the steps here. Let's subtract 45,920 from both sides. And so 100,000 minus 45,920. So now we get to 54,080 equals 143.9x. Now all that is saying is just how many more miles does she need to go? So 143.9 miles per week. How many weeks will it take to go 54,080 more miles, because we've already gone some miles. So now let's divide both sides by 143.9. It's the opposite of multiplying. And then we'll have our number of weeks. So to me, when we solve for x, we get x equals 375.8. And so I can approximate that. Well, how long will it take? About 376 weeks. So she's still got a ways to go. I could divide that by 52 if I do. That's about a little over 7 years. So she's got a long ways to go. She doesn't drive her car very much. But we're using linear modeling and assuming if she drives that same rate for the first 52 weeks, it'll take her 376 weeks to reach 100,000 miles on the odometer. So it's a good planning purposes for her. It's good to know how long will I want to keep this car, maybe before I want to resell it. It just helps us understand this whole situation as we're able to apply concepts like slope, linear equations, average rate of change, and dig into solving this problem. Okay, hopefully that was helpful for you. as you're working on your own linear modeling and understanding word problems.